With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So the question is, which of following statement is wrong? So basically, we have given in the first, if the speed of a particle changes, okay, when you change the speed, its velocity must be changes. Okay. So now let us check. If we say the velocity is basically v vector, okay, and the velocity is denoted as a aik plus bjk plus ck if you have an example for the velocity, okay, and we can find the speed also from this. Okay, speed is said to be what? Speed is said to be under root of a square plus b square plus of what? Plus of c square. By this we can find the speed, okay, and that must be equal to what? That must be equal to the mod of v vector, means the magnitude of the velocity. That must be equal to the magnitude of velocity. This shows that whenever you change the speed of the particle, its velocity be also changed. Okay, this means this is the right option. Now here in the second option, we are talking about if the velocity of the particle doesn't change. If you don't change the velocity, its speed must remain constant. Okay, so here we have given the velocity. Let us consider the same one for the b. V vector equals a I k b j k plus c k cap. As you consider this, and here we have given that the velocity doesn't change. This shows that a b c are what? They are the constant. They are the constant one. So if they are the constant one, this shows when you are finding the mode of v vector, okay, that is also equal to a square plus b square plus c square. So our question is, if the velocity of particle doesn't change, if you take them as a constant, the speed must remain constant. As you can see this here, it is also now equal to the magnitude of the velocity vector. Okay, the speed is basically, now this is what? This is basically speed that we have find. This is speed. Speed is basically equal to the magnitude of the velocity vector, which is root over of a square plus b square plus c square. Okay, so means this shows that b option is also the correct one. Now let us check for the third one, in which we are talking about the speed of the particle doesn't change, its velocity must remain constant. To find this, here we have to consider the uniform circular motion. Okay, let me tell you here very first. If you consider here the uniform circular motion, if we talk about for the uniform circular motion, okay, let us draw the circle. Okay, let's say if the particle is performing a uniform circular motion, which shows what? The particle is moving with the constant one velocity. The the speed is basically constant. In the uniform circular motion, the particle is moving with the constant speed. Okay, here you can see this, the particle is moving with the constant speed, but you can see this, the direction of the particle is changed. Okay, this shows what? That the velocity changes, but speed remains what? Speed remains constant. Okay, so you can take what here, let us write it is UCM, which means uniform circular motion. Uniform circular motion. Okay, uniform circular motion is the best example of this, in which we are showing that the speed remains constant and the velocity is changes, because here the direction of the body is changes, okay, with the time. So now let us move. Okay, so here in this question we are giving the speed of particle doesn't change, but the speed is changes. Its velocity must remains constant, and the velocity is basically what? Velocity is basically changing, and speed is basically what? Speed is basically constant, means this option is the incorrect. Okay, okay, it's right. Sorry, basically in the uniform circular motion, speed is remains constant, as here we have given speed of the particle doesn't changes. Okay, so speed remains constant and its velocity must remain constant, but we didn't find the velocity constant. Here we find what? the velocity is changes. Velocity will not remain constant. Okay, this is the best example of the velocity not constant, but speed is constant. Okay, now here moving to move to the next one, in which we are talking about the velocity of a particle changes. Now the velocity is changing, its speed may or may not be changed. Yes, it's also true. You can understood this by simply taking an example of the non-uniform circular motion. Okay, you can consider here non-uniform circular motion. This shows what? Basically, this shows the particle is moving. The particle is moving, but it is moving with having of some speed. Okay, its speed will not remain constant here. It will be changed or may not be changed. Okay, but it's the velocity. Okay, here the when you change the velocity of the particle or the direction of the particle, okay, means the velocity changes. So speed may be changes or may not be changes and non-uniform. That's why it is said to be what? Non-uniform. But in case of uniform, as I told you here, the velocity is constant. Okay, and velocity is not constant and the speed will remain constant. Here the speed is constant one, or velocity is not equal to constant. Why? Because the direction is changing. Direction change, due to which we can say the velocity is not constant, as the velocity is a vector quantity. Okay, so this shows what the option, this one is the incorrect one. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.